Hello, this is Rafael Luciano, a student with Full Sail University, and today I'll be explaining how some physical laws affect the process of game design. Though video games are generally considered fun and games, there's always been some hard science backing them up. The laws of electricity, magnetism, and thermodynamics play a key role in understanding the way a computer runs. We're not going to be looking at those in this video. Despite the fact that digital games generally run on computers, a game can exist outside of a computer simulation. So, for that reason, we're going to look at how real-world physics affect specifically gameplay mechanics. Let's take a look at one of the most basic physical laws, universal gravitation. Newton's law of universal gravitation states that every object in the universe attracts every other object, the attraction being more proportional to the product of their masses, and inversely proportional to the square of the distance between them. Now that might sound a little bit complicated, so we can break this down to mean that force is equal to mass times the acceleration of gravity. You can also remember this as F ma, or force equals mass times acceleration. In our world, this free-for-all acceleration on Earth is equal to a downward acceleration of about 9.82 meters per second squared. You can see here, ignoring air resistance, that if I drop this Goomba and this box from about the same height, they both hit the ground at generally the same time. This is because of universal gravitation. How does this affect game mechanics? Let's take a look at everyone's favorite plumber, Mario, to see why. Now as game designers, we are not limited by physical laws, though we can alter them a bit and match them to real world, but we generally adjust them to better match gameplay and create more fun. In most games in the series, Mario is about 5 feet tall and can jump 5 times higher than his own height. That's incredible. Over the years, the velocity of Mario's jump has come closer and closer to matching the real-world value of about 9.82 meters per second squared, but he's not quite there just yet. As Mario drops down, however, he accelerates at an incredible speed of 43.05 meters per second squared. Now, for a real being to do this, they would have to suddenly gain an incredible mass just before falling to account for that increase in speed. Not to mention that a fall of that speed would kill most real-world people. But why did Mario's designers do this? We can see just how falling quickly affects the gameplay, because as Mario reaches the ground quicker, the player can gain control over Mario again much more quickly and can better avoid obstacles, creating for a much more enjoyable gameplay feel and feedback for the player. Well, that's all I have for you today. You can check the source of the original research down below if you're interested, and thank you again for watching. Hope you have a great time.